Alright, so welcome back. We're going to go ahead and continue discussing some examples in section 7.4. And so in the previous video I just showed you kind of where these, or some of these identities came from. And so in this video I want to show you just how we go about applying these to certain problems. Maybe similar problems to the ones that you might be experiencing on your homework or an upcoming quiz or something. So let's just dive right into example 1. Example 1 says, given cosine of theta equals 3 over 5 and sine of theta is less than 0. So remember what this means. This means that sine is negative if it's less than 0. They'd like us to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Well, okay, so because they're asking for 2 theta, it looks like we're going to be using our double angle identities here. And they give us that cosine of theta, not 2 theta, but cosine of theta is 3 over 5. So it looks like I need to figure out, well, first, what is sine of theta? Regular theta, not 2 theta. And so for that, I'm going to go ahead and just kind of think back to this identity here. So I'm going to start off with the Pythagorean identity, the cosine squared plus sine squared of theta is equal to 1. And I'm going to substitute what I know. So I know that cosine of theta is 3/5. So this is cosine squared. So this is going to be 3/5 squared plus sine squared equals 1. And now I just have to clean this up. And so if I look at this here, 3 squared is 9. 5 squared is 25. Plus, and I'm just going to bring this stuff down here, equals 1. So now what I want to do is just kind of solve for sine squared. And so if I move, or if I subtract, so minus 9 over 25 on both sides, well, I'm left with, let's see, this is going to go ahead and cancel out. Let me go ahead and, that would go ahead and cancel out. And I'm left with sine squared of theta is going to equal 1 minus 9 over 25. Now here you have to get a common denominator, and so our common denominator here would be 25. So think about multiplying that 1. That 1 would turn into 25 over 25. And so if you think about 1, I'm just going to go ahead and rewrite the number 1 here, but the number 1 is simply just 25 over 25, that's still 1. 25 minus 9 is 16 over 25. And then again, I don't want sine squared, I want sine. And so I'm going to go ahead and just take the square root so I can get rid of that. Square. And just keep in mind that whenever you take a square root, you're going to have a plus or minus. And again, sine would be 4 plus or minus 4 over 5. The square root of 16 is 4, square root of 25 is 5. But we got to remember our condition here that sine is less than 0. So we're going to say that sine of theta is going to be the negative solution, so negative 4 over 5. So if you think about what we now have, oops, let me go back really quick. We now have cosine of theta. Okay, and now we figured out what sine of theta is. And so what I can do now is try and use these identities to kind of help me out. So the first thing that they want is they want us to find sine of 2 theta. So if I look at the identity, the formula that's up there is sine of 2a, and that equals 2 sine of a times cosine of a. Well, we're just going to be substituting theta into this. So this is going to be sine of 2 theta is equal to 2 sine of theta times cosine of theta. And we just have to ask ourselves, okay, do we know sine of theta? Do we know cosine of theta? And yes, we do. Cosine of theta was given. Sine of theta we had to find. And so we can go ahead and get our first part here. So sine of 2 theta is equal to 2. And then again, sine of theta is negative 4 over 5. And cosine of theta was 3 over 5. And again, we just have 3 fractions here. We can think about this as 2 over 1. And again, to multiply fractions, we just multiply straight across. So 2 times negative 4 2 times negative 4 is negative 8. Negative 8 times 3. Negative 8 times 3 is negative 24. And then for the denominator, we're going to have 1 times 5, that's just 25. And so sine of 2 theta, it looks like sine of 2 theta is just going to be negative 24 over 25. And that's how we go ahead and apply the definition. What I'm going to go ahead and do is just delete or erase this part right here. So just give me 1 second so I can have some more room. And I'm going to go ahead and try now and find cosine of 2 theta. So now I'm going to try and find this guy right here. And so cosine of 2a, if I just look at my formulas here, I can use any one of these formulas that I like. So I can use the first one, cosine squared minus sine squared. I can use 1 minus 2 sine squared, or I can use the last one. I'm just going to write the first one, cosine squared of a minus sine squared of a. And I'm just going to go ahead and substitute theta. So we're going to have cosine of 2 theta. Well, that's just going to be cosine squared of theta minus sine squared of theta. And again, all I'm going to do now is just substitute with theta what cosine of theta is into this equation respectively, and as well as sine. So we're going to have cosine of 2 theta is equal, let's see, cosine is 3/5, so this is cosine squared, so that's going to be 3/5 squared minus, now here sine squared is negative 4 over 5, or sine, I'm sorry, is negative 4 over 5, so sine squared would be negative 4 over 5 squared. And so we have this set up here. We just have to clean this up a little bit. This shouldn't be too bad to do, so we're going to have cosine of 2 theta is equal to, let's see, 9 over 25 minus here negative 4 squared, that's going to be 16, 5 squared, let's see, 5 squared is 25, and then we just clean this up here. So 9, let's see, so to do the fractions, all we have to do is just do the numerators. So we're going to have 9 minus 16 in the numerator. That gives us negative 7. And then for the denominator, we're just going to stay at 25. And so we figured out what cosine of 2 theta, what that equals. And so we're just going to say that's negative 7 over 25. We can do the exact same thing for tangent of 2 theta. I would just have to use this identity here. I'm just going to go ahead and skip over that. I'm sure that you get the idea. All you would do is just, again, just substitute what your values are. Now, just all you have to remember for tangent of theta, just to kind of get you started, because you are going to have to find tangent of theta. Tangent of theta is just sine of theta over cosine of theta. And so if you think about sine of theta, that was negative 4 over 5. And if you think about cosine of theta, that was 3 over 5. And then you can go ahead and simplify that. Again, just multiply by the reciprocal. And now you have your tangent of theta so that you can go ahead and plug in to your identity there. Whoa. Okay, so let's go ahead and look at the other problem, the other example, because this is kind of what I wanted to get to. So example 2, we have to simplify each expression. So again, they give us this cosine squared 7x minus sine squared 7x, and so I need to kind of clean this up. And so hopefully this looks familiar. If I just write it like this, cosine squared of a minus sine squared of a, and if you look at your double identities, what does that look like? So if I go back up really quick, let's see, scroll through this mess. Hopefully you see that cosine squared of a minus sine squared of a just equals cosine of 2a. So if I come back down, let's see, this right here should just equal cosine of 2a, 2 times a. And the question is, okay, well, what is a? And so if you look carefully, it looks like a is just this 7x. And so it looks like this here should just equal cosine of 2 times 7x. And if you just clean that up, well, cosine of 2 times 7x, I'm going to go ahead and just put a little arrow here, just to know that this is cosine of 2 times 7, that's going to be 14. And so really this expression right here, cosine squared of 7x minus sine squared of 7x, is simply just cosine of 14x, and that would be our answer there. So it's just a matter of recognizing which identity you're using. And that's pretty much all there is to it. But let's look at part B really quick. Part B has some stuff going on. So we have sine of 15 times cosine of 15. Now let's try and find something that looks like that with our double identities here. So if I scroll back up again through this mess, we had sine of 15 times cosine of 15. And so I didn't have any squares there, so I'm not going to use that one. And I won't use this one or this one. So it looks like all these three identities right here on the left side are out. This one right here has a tangent involved, and my problem didn't have a tangent. Well, it looks like it has this. I mean, we do have sine of 15, cosine of 15, but we don't have this 2. So that's fine. I mean, this is kind of the closest thing that we can use. So let's at least start off here and see where the problem takes us. And so what I'm going to do is just start off by writing the formula. And so it was, let's see, we had sine of 2a is equal to 2 sine of a times cosine of a. And what we have is just sine cosine 15. So what we have is we just have this part right here. And so it looks like I'm missing something. And so let me try and start filling in some things. So for example, it looks like I have, let's see, I'm going to do this in blue. Looks like I have the sine of 15 part down. Okay. And so what I want is I need a 2 to be here. So if there was a 2 here, then this would definitely equal sine of 2 times a. Now I just need to think about what is my a here. Sorry, 15 degrees. And so it looks like a is going to be 15 degrees, and so I'm going to go ahead and fill in the 15 degrees there. And so this would be really nice, again, if this 2 existed. This is only if this 2 existed, this is what it would equal. Well, let me just go ahead and continue with this problem and see what happens. So I would have sine of, let's see, 30 degrees, because 2 times 15 is 30. Well, that would equal 2. And then I have this, let's see, sine of 15 degrees wrapped up with this cosine of 15 degrees. Okay. Well, I'm almost done. I just need to figure out what this is. Again, I don't care about the 2. The 2 we just added so that we could make it look like the formula. Well, what happens? Well, first of all, I guess before we even do that, I guess let's ask ourselves, what is sine of 30 degrees? So sine of 30 degrees, again, go to your unit circle, find the 30-degree mark, and ask yourself, what is sine of 30 degrees? And hopefully you're looking at it and you're seeing, or maybe you just know this off the top of your head, but it is 1/2. So we have 1/2 is equal to 2, and then we have sine of 15 degrees and then cosine of 15 degrees. So the question is, well, how do we get rid of this 2? Well, I can simply divide by 2, or I can just multiply this by 1/2. That would be the same thing as dividing by 2, and so this cancels out. But if I multiply by 1/2 here, then I would have to multiply by 1/2 here. And so notice that I would get 1/4 would equal sine of 15 cosine of 15. And so that would be my final answer there. That sine of 15 degrees times cosine of 15 degrees is simply just 1/4.